Welcome to another episode of Women Winning at Work with Barkha Herman. And today I'm very excited. I met Ginny Foster, who's our guest today, online, of course, as one does these days. And it was so neat because she's into robotics and AI and all the cool things that I love as well. And so I'm going to have Ginny introduce herself. Ginny, in your own words, can you tell our audiences what you do?
Yes. So my name is Ginny Foster, and I am Market Development Manager at Neff Power. And I help connect engineers who are looking for automation solutions. I help connect them with industrial automation solutions and with robotic solutions so they can automate their processes.
That sounds wonderful. So the next generation is here. I'm always very excited when I have someone like, I come from 30 years of career in computing, so it's like coding, coding, coding. And when I encounter somebody who's into either blockchain or robotics or, even quantum, that's cool. So welcome.
Thank
I
you.
would, yeah, I would love to hear your origin story. How did you get here? What was your path to automation, robotics? It just sounds so exciting.
Well, thank you. So, first of all, Barkha, I just want to say thank you so much for reaching out to me because your message of positivity and growth, it really resonates deeply with me, and I'm just thrilled that you have invited me here to your podcast. And it's really validating. It's hugely validating to have someone such as yourself reach out to me and recognize, like, oh, she's doing it. So I appreciate that so much. And I mean, we should not be looking to the outside world for validation to tell us we're doing great. And I think that's one of the themes I want to talk on a little bit later. But starting off with my origin story. So, as a child, you would never have pegged me to be an electrical engineer. I was into climbing trees and playing outside, and I loved playing in the sandbox. And, I never really gravitated toward computers. I think the one time I really got excited about using a computer was in grade school. I had a best friend who lived down the street, and we would play Oregon Trail, and then we would use the paint program to make maps, and then we would totally waste all of our family's ink printing out these maps. So that was really the extent of my relationship with technology when I was younger. And I went to an all girls high school, for which I'm very grateful for that opportunity. I felt like that really prepared me for opportunities such as these, in which, I get to communicate and connect with people and really help explain what the technology is all about.
Mm.
When I went to university, I quickly realized that everything that I had learned was covered in the first 2 weeks of class. So, from that point forward, I I had to rely on what I call project-based learning because
Mm.
I realized that in order for me to learn something, I was probably I wouldn't say behind, but I definitely had gone through a different track than most of my cohorts who were in engineering school. So, in order for me to gain the skills and gain the understanding that I needed, I really had to be careful about the projects that I selected. And I also had to develop my own trajectory, my own path for learning. And so that's why I sought out summer math classes. And I actually took 4 summers worth of math classes at the community college. And by that point, I really appreciated what math was. I appreciated the language of it. I appreciated what equations would help us understand and what the use of variables would help us do in terms of describing the world around us. And especially graphs. Now that I'm out of engineering, I absolutely love and adore graphs because they tell stories. It's all about, one axis with relationship to the other axis, and it's describing possibly over time, but it could be with respect to other variables, how these two entities are related to each other. So that appreciation took a very long time to develop. And it was only after I had taught myself to learn that I
Mm.
re enrolled in engineering. And that's when I felt like the rubber really met the road. So I've spent much more time studying engineering than most people. I've spent 8 years studying engineering. And when I graduated, I was really interested in projects. And that's because this is only looking back at it now, but I was interested in projects because I intrinsically understood that through those projects I would learn tangible skills. And so my
Right.
first projects involved engineering design. And through those projects, it was a series of 3 projects. I ended up with my name on 5 patents. And just this past year, a
Wow.
6th patent was added. So I can now say over the span of 3 projects, my name is on 6 patents, which is, it's wonderful to say these things. It's great. Um, it was the tangible skills that came out of the projects that were truly valuable. And looking back on the projects, I was like, well, what is my favorite part? And my favorite part was always interacting with the people in the field with this new, unique, and non-obvious application, which those are the 3 criteria for patentability: new, unique, and non-obvious. So interacting with people was my favorite part, and I looked it up to see if it was an actual career, and and it was. So I tailored my resume to match that of a sales engineer, and then I landed my first job in the foundry. Uh, I landed in metals and mining at an
Yep.
international foundry, and it was just an absolutely wonderful experience for which I'm so grateful to all of my mentors. They were incredible figures, and they really set examples, very high examples for both communication as well as the customer service experience and safety and everything that you needed in order to survive in a very heavy industry environment. And it's interesting to me that the reactions of my peers, especially my female peers, I was a bit confused by their reactions because they did not see the beauty and the camaraderie and the connection that truly comes from manufacturing. And instead, they warned me about the monotony of factories and the dull, dangerous, and dirty environments that I would be in. And the irony of this is that now I help solve those problems with robotics because robots are perfect for dull, dangerous, and dirty
Mm.
tasks. So I help connect engineers who have highly repetitive and ergonomically challenging tasks with the right robots and the industrial automation solutions to improve their processes.
Wow, there's so much to unpack there, and I'm so glad that you're actually sharing this story with our listeners. So, first of all, I always thought that math, I was good at math. I was quote unquote naturally gifted. And I found it extremely frustrating that people didn't see the beauty in math that I did. And then I got to the point where I started paying attention to some of the teaching patterns. And I think that the way math is taught may be one of the reasons why, because I had some inherent insights that others didn't. And it took me working with, and I used to tutor younger kids, even when I was a child, to realize that they had it all wrong. And that's why, the whatever time it takes to have the foundation is worth it. It's so worth it. So that's why I love your story, because I think the reason you start with projects and end up with 6 patents is because you didn't kind of pretend, oh, I get it. You took your time to understand the foundations, and that's what leads to. So to me, that's such an inspirational story. I love the fact that, it took you longer than usual. And to me, that speaks to following your dreams. And if it takes a little longer, we kind of we put ourselves in these cookie cutter, whether it be being girly or finishing your degree in 4 years, or summer class is bad, or whatever else, kind of cookie cutter definition. So what an amazing story. And I love, when you speak, I can hear the passion. I can hear the love for your work and your voice, which is very inspiring. Thank you for sharing.
Well,
Um,
thank you. And to that point, to the point of the frustration, because I know there might be a lot of people who are listening who may be frustrated with where they are now and they're looking down that trajectory and they're saying, oh my God, it's going to take forever. There's a resource that I want to share that I wish I had,
Mm.
and it is this book. It's called
Oh,
Mindset
my
by
favorite
Carol
book.
Dweck. I love this book. So if I had read this at the beginning, I probably would not have been so frustrated with what I thought was my plight of needing more time and needing a firmer background in math. And I'm definitely very grateful that I stuck with it, but that stick with
Mm.
itness, it's hard. It's very hard to create within oneself the resilience necessary for that. And that is something for which I'm proud of myself. And for everyone else who has gone through similar situation, I'm proud of them too.
Yeah, yeah, no, that's so great. And it's almost, and you know, I love that book, and it's almost like having a gift is a curse because you don't build the stick with itness muscle. And fortunately for me, as I mentioned to you, I was surrounded by a bunch of brothers, and so they kind of taught me to be the tough person. So it came in other areas for me, but I did learn it eventually, which is great. Wonderful. So the next question I have is, I know you mentioned some of the positives of going to an all-girls high school. So I do want you to expand on that, but I also want to talk about what were the biggest challenges of being a woman in this world? You know, electrical engineering, working for a foundry. Oh my goodness, you know, so many stories.
I
What
think
was, yeah.
okay, so for me, the biggest challenge was actually communication, which I
Mm,
never would have anticipated. And that's due mostly, in fact, to the environment. It's very loud, and you have to wear full PPE, which is personal protective equipment. So you have to have the hard hat, the safety glasses. Sometimes you have to wear a mask if there's fumes involved, gloves. You can't wear jewelry, which I was frequently ignoring that, and I kept my earrings in, which I should not have. So shame on me. But also, you have to wear the boots, the steel-toed boots with the metatarsal protection. You also need to wear the leather chaps. If you're anywhere near the melt and pour furnaces, you would need to wear a full body apron made of leather to protect you from any splashes. So, in a foundry, you know, if things are on fire, that's pretty normal. So, if it's not smoking, if it's not burning, that's there's something going on. So in this environment, you really have to learn how to communicate with body language and really project your voice. And for me, I am so soft spoken. The projecting of one's voice is my biggest challenge. And
mm,
the other part of it is my mentors were so good at speaking. They were excellent at speaking on the phone. They were excellent at speaking to groups of people. And oh my goodness, the presentations that they gave were always
mm.
wonderful. So I was very inspired by their level of communication. And so I looked up how can I become a better public speaker? I looked it up on Google, and that led me to Toastmasters. And there's Toastmasters organizations all over the world. I found a local Toastmasters club. I joined the club, and it was just a huge opportunity, both in terms of personal growth as well as professional growth. Because just last year, I was invited by a friend and a connection from Toastmasters. Years ago, we were in Toastmasters together, and she had landed this amazing job in the UK, and she invited me to be the subject matter expert for robotics on her podcast.
Wonderful. That sounds so great. But yeah, no, I could just visualize being in a factory environment and having to project and being larger than life. That's beautiful. That's great. What is the and you know, it does remind me in a previous life I used to be a chef, a professional chef, and I was the only woman. I was the first woman in the history of the kitchen to work there. So I used to have famously short hair all my life, and now you know everybody knows me for having very long hair, and it was the chefs who made me grow my hair because the only way they could tell me from behind was if I had a braid. Braid, they could tell, oh, it's her as opposed to a guy because everybody looked the same in the outfit. But that's funny. What is the superpower of being a woman in that environment? What was the good about being in the tech industry? the factory space and also in your current job?
I found that when being a woman in this space, you're a little bit more rare as a
Mhm.
just you're a little bit more of a I guess of a unicorn. And so when you have something intelligent to say, people do stop and listen. And even if you are soft spoken, they will lean in closer to hear what you're saying because they know that it's definitely worth hearing. And it takes years of experience of being surrounded by, challenges and learning how to solve those challenges that gives you that expertise so that you do have that gravitas when you go to speak.
Yeah, yeah, no, very true. And I always, you mentioned Toastmasters. I also was part of Toastmasters, and I always toy with the idea of creating a women in technology Toastmasters club and call it Wit Toast.
That would be amazing. I I would love to be part of your Toastmasters club. If that's something that you want to run with, I would totally be
Yeah,
a part of
well,
it.
so just focus on, just focus on women and have them speak at more events, and because that's my passion, lifting up women in this space and seeing more female voices in those areas. But that's one of the advantages that I've found is that I am heard because I'm one of so few, and so that's wonderful to hear. What is an advice that you would give your younger self or somebody who is wanting to do something, either follow you in your footsteps or create footsteps of their own, which is similar but not the same as yours?
Well, this is where I would talk about that internal versus external validation. So, internal validation, it's for you. It's for you on your path, on your journey, for you to decide what skills you want and for you to measure your own success and for you to learn from your own failures. The external validation is for your product or for your
Mhm.
project. And when you go to seek external validation from end users in the field, because this is part of what we do normally as engineers, it's about the solution. It is
Yeah,
not about you as a person. And that is really crucial.
that's a great distinction because I think that people reject people reject, solutions or ideas, and sometimes we take it personally. I know I have to struggle with it even today. It's not a daily thing for me, but it happens, right? You really feel like you have a connection with a customer or solution and they reject it, and it's like, "Ah, I was rejected," as opposed to. So that's great insight that you have. And what have you learned having the career that you've had? What would you love to share?
In terms of sharing about my career, I love sharing about it. So I work for Neff Power. We are an industrial automation distributor and robotics partner, and we help our customers source the right tools and the right solutions to automate their processes. We utilize technology in robotics, in safety, in aluminum framing, electrical control, in motion control, pneumatics, and hydraulics. So we encompass all of the technology that helps automate processes. And we partner specifically with our customers. We partner with them in robotics so that we can train them on site and also we can train them here in our lab. So, what we love doing is proving out proof of concepts. We have a robotics lab, and you can see videos on our YouTube channel. We love throwing in a new idea, just a new concept, and we're like, well, how can we make it work? And so, in our robotics lab, we try out new end of arm tools, we try out new conveyors, we try out new arrangements, new safety devices or safety solutions. So, really, it's that's what we have fun doing is teaching our customers so that they can scale within their own facilities. And recently, we discovered that the majority of successes in robotics, they come from having a robotics champion. So
Mm,
we realized that our customers who get the most ROI out of their robot, they have a dedicated person on site who is the in-house champion of robotics. And about 3 months ago, I had the honor of leading a 3-day course on how to become a robotics champion.
That's
And
awesome.
oh my
Yeah.
gosh, it was so awesome. It was the first time I'd ever led a class. So I was really amazed that I could just keep talking, and 3 days was not enough to really get into the weeds with all the details. So just a really overarching view of how to become a robotics champion. It's about how you think. It's how you
Mm,
think about your process. And the easiest and the most lowest hanging fruits in terms of the processes that you can automate with robotics today are the ones that involve two characteristics. They involve repetition and they
mm,
involve ergonomics. So if you have a motion that you or another person repeats over a long span of time, could be several hours, could be several days, and it involves discomfort to the human body in some way,
yeah.
that is the first application that you should think about automating. So how do you envision this? Because a lot of times people are like, okay, automate it, but I don't know what that means. To visualize what that means, close your eyes and just let the environment fall away and imagine just the target object that you plan to have involved in your task. Not necessarily the tools, just the object. It could be a final product, it could
Mm,
be something that you're working on to get to the final product. How that object or that product moves through space and the orientation that it has and the motion that it has in 3 dimensions, that will determine the type of gripper that you will use to interact with
mm,
it.
yeah.
And there's all kinds of grippers, but don't worry about them. But there's all kinds. There's mechanical, vacuum, magnetic, electromagnetic. But don't worry
Yeah.
about what exists. Instead, worry about what you need to do in order to move from point A to point B. And then once you know how your product is going to be oriented in space when it gets from point A to point B, say you have to do a turn or you have to do a push forward or a rotation. Once you know how you're going to do that, then you know how you're going to grip it, and then you start to think about your robot. So don't think about your robot first. That's a mistake that
Mm,
we see a lot of people go into. They first pick a robot. They're like, okay, we're going to pick one first, and then we're going to find an application for it. Look at your application first,
yeah.
then select your robot
Yeah.
because there's so many things involved, especially payload, because your payload is going to include both your target object as well as your end of arm tool. And if you happen to have a very heavy target object plus a very heavy end of arm tool, you may have actually scaled up to a larger size robot and you didn't know it.
Mm,
So, other variables to think about are maximum reach, so the distance that your robot will need to extend and retract, your cycle time, so how fast your robot's going to do this, and then also the number of axes that you want your robot to have,
mm,
which is probably determined by how your object is going to be moved throughout space and time.
right. Right. Yeah.
So
No, that's fascinating. And it's funny you're talking about robotics and I'm visualizing the 3D image in my head, but I'm also thinking how applicable this is in every problem solving because it's very basic. We start with a vision of what the end product is rather than vision of the problem that we're solving. And that's where we fail or have to iterate many times to get to the real problem. So that's really
oh my
really
gosh,
neat.
yes, because this is what is taught in engineering school. It is define the problem, define the given variables, and then define the variable to which you will solve. And that's like the simplest part of it's the easiest part of every single engineering problem.
Yeah, and
Um,
and the funny thing is when I mentor people, I mentor young women, they always say, well, this is the problem, I'm having a problem, and I always ask them, what are you solving for?
yeah. So it's the same concept. It's how to define your problem and then solve for it. But one of the unique factors is that you can also, with robotics today, you can also start to involve more and more people, and that's where you start to hear these industry terms: collaborative robotics versus
Right.
industrial robotics. And collaborative robotics are the ones that can involve human beings walking in and out of the workspace. The robot will slow down to a safe speed when they approach, and then will stop when they're within the reach of the payload. And And there's a trick to this, and there's a trick that
Mm,
we show in a lot of our videos on our YouTube channel, and that is that you can utilize the right safety equipment and the right safety devices to get an industrial robot to behave like a collaborative
mm.
robot. So truly, you can take advantage of the high cycle time and also take advantage of the interaction of human beings with the right safety devices.
Yeah. And again, being the geek I am, I keep thinking, okay, Asimov's laws of robotics, there's an analogy in that, the safety versus.
And we call it stop state monitoring and speed and separation monitoring. And it's if you're thinking about like robotics and sentience, this
Of
may
course
be as
not.
close
Of
it
course
this
not.
is as
Yeah.
close as it gets, but this is
Yeah.
where we are telling we're literally telling a safety sensor to communicate with the robot functional safety unit so that the robot knows when the person is in the vicinity or not. So you can see videos of our YouTube channel.
Yeah, yeah. Oh, so I
Yeah.
definitely will post the links to all your links. And I know that you do host a podcast as well. So I want to hear, what is it called? Where can we find it?
So we have the Neff Power podcast, which at this
Okay.
point is a compilation of all of the guest appearances that our Neff Power engineers have participated in on other podcasts. But we are really looking forward to having more and more Neff Power podcasts to the point where we actually have our own. And we also do have a Spanish language podcast as well. It's Neff Power in
Wonderful.
Espanol. So we are adding to that slowly over time.
That sounds wonderful. That sounds wonderful. Oh my goodness, what a interesting conversation. I want to wrap up, but before I do, is there anything else you want to share, personal, professional, anything, words of wisdom with my our audiences?
Yes. Yes. So if you personally are looking to get involved in the robotics industry and you're thinking to yourself, okay, I need to understand how this works, my advice would be to look at as many just watch as many videos as you can and understand that you as a human being who knows how to utilize a smartphone, you as a human being have all the tools that you need in order to teach a robot its first job, its first task, its
Mm,
first application. And that is because touchscreens have completely lowered the learning curve. With the use of touchscreens, you can you can literally interact with how the robot will move through space with a couple button presses and
mm.
go. And a good example of this, we had a 7-year-old. We had a 7-year-old come to our robotics lab, and we were really curious to know if this would work with him. So we were like, "Hey, you got a toy car. If you put your toy car on the table, can you make the robot pick it up and can you make the robot fly it around and can you make the robot land it again?" And he did it. And he did it without touching the toy car. He had the robot do the whole thing, and it was in 35 minutes and 17 seconds.
Oh my goodness. And
Yeah,
I hope that you have a video of that.
we do. It's on our YouTube
Okay.
channel too. Yes.
I definitely will call that out as a separate link and share it. So that's
Excellent.
fantastic. Well, Ginny, thank you so much for being on my podcast. You're such a wonderful conversation. You're an inspiration to me, and I'm sure to my listeners as well.
Well, Barkha, thank you so much for this opportunity, and I really enjoyed talking with you. And I hope we can do it again.
Absolutely. Absolutely.